Hi, this is Kevin, and welcome to the tutorial for the logical database design assignment. Let's just take a look at the instructions first. We're going to be creating a logical database design expressed as an ERD, okay? And we're going to start with a conceptual data model, okay? And you can start with either your conceptual data model from your last assignment or my solution to the same assignment. You can choose. Or you might want to create a hybrid of the two, okay? But feel free to use mine, okay? That's your starting point, okay? Uh, or yours, or some hybrid. What's the deliverable? Well, you're going to be turning in an ERD. All right. What's the scope of the model? Well, the scope is going to be the same scope that we used for the assignment on conceptual data modeling. So you can refer to those instructions for details, but anything that was outside of the scope of that assignment is outside of the scope of this assignment. And anything that was in the scope of that assignment is in the scope of this assignment. Okay? Now, remember that because this is a learning problem, okay, and you don't have real people to go talk to about the requirements, you don't have project stakeholders, well, then you have to make some assumptions. All right? Feel free to make reasonable assumptions about the problem. Okay, so sort of imagine that you've gone and you've talked to the stakeholders and you've asked them, do they want to do X or do they want to do Y? And here's what you think the implications are. And they give you an answer and you come back and you implement it in your model. Okay? Because we don't have real people to talk to. But when we get to the day job, we will, in which case we'll talk to them. Okay. Now, the steps of the logical design process I've laid out pretty explicitly on within my lecture. And what I did is I took the notes that I used for the lecture and I converted the mind map that I had there to an outline. Okay, and so the outline includes make final improvements to your conceptual data model based on stakeholder feedback, then normalize the data model, and then adapt your design to relational database technology. So I'm going to leave this outline on my other monitor and we'll come back. Okay? So let's do that. So here's what I have. I have here just a copy of the ERD that I did for the conceptual data model. The problem that I'm doing here in the tutorial is a follow-on to the work I did in the tutorial for conceptual data modeling, and it's for the student attendance system. And what I did is I just copied over the ERD. How did I do that? Well, within Lucid Chart, I loaded up the ERD, okay? I think it probably warned me that since I had created another couple of diagrams since I created that diagram, that I was no longer able to change that ERD. That was okay because I picked File, Duplicate. And it went to duplicate and I said create the document anyway. And that what I did is I gave the duplicate the name instead of conceptual data model 4, it said logical database design 4. So that's how I got to what you see right now. Okay, so what's step 1 according to our outline? Okay, make final improvements to the conceptual data model based upon stakeholder feedback. Okay, and when I say stakeholder feedback, I want to include any misgivings that you've had in the meantime. Okay, what happens to data modelers is that, to a certain extent, you're never done. Okay, these kind of decisions, you choose between A and B, or you choose between A, B, and C, and then you feel good about the time, and then as days go by, they kind of haunt you. Oh, okay, so either ideas that you got from stakeholders or ideas that have come to your mind since, and what are you looking for? Well, you're looking for making different decisions about the things we did in the last assignment. So, do you have any missing or incorrect entities, right? Well, if you do, fix them. Do you have any missing or incorrect relationships? Do you have any missing or incorrect attributes? And between attributes and relationships, it's really important for new data modelers to realize that relationship instances are facts and attribute instances are facts. And you also might decide that something that you modeled as an attribute you want to turn in to a relationship, to a lookup table, or vice versa. Okay? Missing or incorrect unique identifiers. Are your identifiers okay? And then I don't really encourage beginners to make a lot of use of supertypes and subtypes, but it might be possible that you've used it, or you're thinking that you want to use it, and you may want to revisit that. So all those things you can revisit. So let's take a look at my conceptual data model for the current problem. And the one thing that I've rethought is over here when it comes to users and permissions. Okay, well, let me undo that mess. Okay, over here, let me roll up. Whoop, there we go. So, the way I explained this when I did the last tutorial, the users that we have are users of our system, right? And the user stories are kind of functions of our system that the users are going to do. And so I had the relationship between user and user story. But what I really forgot is that it's a pretty typical design feature of most online systems that they're usually, that part of the design is usually expressed in terms of users and roles that users can play. Okay, so how would this be different? Well, a user story, in our case for something like this, is I think the user stories that I had for the instructor user was that they could set up a course, they could set up a section, they could set up a student, they could set up all these things. So those are all the things an instructor can do. Okay. Now, do I need to record the permissions at that final level? No, I really don't. I just have to say that a particular user is able to play the role of instructor, okay? Or a particular user is able to play the role of student. Or a particular user is able to play the role of system admin, okay? So here's what I want to do. I want to change user story to just role. They're able to play a role. So I'm going to change this to role ID. Okay. And I'm going to change this to role name. Okay. And I think I want a description. So I'm going to add one more field. And I'm going to call this role description. Okay. And I'm going to get rid of that key text. And I think that works well. So I've turned the role, I've turned what I was calling user story, which is kind of a systems analysis a term. I've really taken it to typical system design features for aligning systems of user and role. Okay, do I like user? Well, I noticed that I don't have a name or a password or anything. Now, I understand why I don't have a name. Okay. Um, Even though I haven't used um, a superclass subclass organization here. Okay. Uh, and why haven't I? Well, one is that I'm reluctant to use supers and subs. I use them as a last resort because in relational databases they're very clunky to implement. So, we're not. It's not like they take you to some great set of features in relational database that are easy to implement. But I think I want to rethink these three. Okay. So, uh, instructors have a first name and a last name. Students have a first name and a last name. They also have a university ID number. Okay, so these things look um, pretty much the same. Okay, the only problem is that uh, it's it's possible on some kind of a level. It's possible that a person could be a student and an instructor at the same time. So how could that happen? Well, let's see. I could have a doctoral student who's a student in one class, and they are teaching another. Okay. And usually in relational databases, if you're going to have a super sub relationship, you want the subs to be disjoint. So there's at least a potential that they wouldn't be, they'd be overlapping. So here's what I'm thinking I'm going to do. Okay. I'm going to do like everything except officially call this super sub. Okay. Um, so what am I going to do? Well, first of all, in user, I definitely need to get a password. Okay, so let's add a password. Definitely going to want that. Okay. Um, and do I want to move the first name, the last name, and the university ID number over to superclass because they're going to share them? Um, I'm thinking not. I'm just going to leave these things kind of parallel to each other. I think that's where we're going to wind up in the physical database design. Is that messy? Yeah, I think it's a little messy. It's not perfect, okay? But I think that um, this is going to make my design work as well as I want to. Is there some duplication in it? Yeah, I think there is. Okay. Uh, but could we have expressed this in terms of supers and subs and then worried about how to implement it when we got to physical database design. Yeah, we could have. I just it decided I wasn't going to. All right. Okay. So I've got the user, I've got the role, instructor and student. They're looking okay. Um, I have course sections, class meetings that happen for each course section. I like that. Each course section is for a semester. A semester has a year and has a period. Okay, and each course section is for a course. I think that's pretty good. Okay, so at this point, I consider that I have checked off part one of the outline. And now I want to go down to part two. Okay, so we're going to normalize the data model. Okay, now one of the things that you're going to see here is a lot of the normalization is already done. Now, why is that? Well, because if you do your conceptual data modeling in a thoughtful way, and if you follow kind of the practices that I've encouraged in my course for conceptual data modeling, which is to do things like control values in those kinds of things and eliminate redundant facts in the database, that we've kind of pre-normalized a lot of things. Okay, so you probably won't be too surprised as we go through the list here if you find out that there isn't anything to be done, because we kind of took care of those issues in conceptual data modeling. So the first thing is removing repeating elements. So we're looking for any attributes that might contain a list. We're looking for repeating attributes like skill 1, skill 2, skill 3. We're looking for repeating attribute groups. Okay, do we have any of those? Let's go look. So I don't think we do. Okay, we don't have any in course or year or semester or period or course section or instructor or student or user or role. Okay, would it have been possible to have created a list somewhere? Well, or some kind of repeating attribute. I think our best opportunity here would have been the following thing. Let's say that we wanted for each user, we wanted to list out the roles that they had permission to play. Well, maybe we would have put on the user role 1, role 2, role 3, role 4. That's not the relational way. That's not normalized. Okay. But we didn't. We thought ahead. Okay. We created a role entity and a relationship to it where we currently have a many-to-many. And so we don't have a problem with repeating elements. All right. Okay. We might have had. So remember to look at yours, and if you have them, well, you should know how to solve them. I give, I think, good examples of how to solve them in my lecture. Okay, so let's look about redundant attributes. So truly redundant attributes is the first thing we want to look for. Okay, do we have any redundant attributes? Again, I don't think we do. Okay, let's look at all the tables at once. We're going to zoom to content. Okay. Okay. Everything on course has to do with course. Year has to do with the year. semester the same, period the same, course, section, instructor, user, student, role, class meeting. I don't see redundant attributes here at all. Now, what would a redundant attribute look like if we had made that kind of mistake? Okay, well, um, here's what it might look like. Okay, what if we had put course number right in here? Okay, what if we had made this one thing bigger? Okay, it's always a little bit hard to move this. Well, I tell you what, we're not going to make it bigger. We're just going to talk about what we would have done had we done it wrong. What if we put the course number on the section or the course name on the section? Okay, don't those things have to do with the section? Yeah, they do. Okay, but they don't really belong to the section. The course number and the course name actually belong to the course. Okay, so it's entirely possible for us to have accidentally put them on the course section and the course at the same time. And we go, oh, no, we don't need to put them on the section. We just have a relationship to the course and they're on the course. Okay, so it's that kind of problem that you're looking for. And if you want to see other examples of how to solve that kind of problem, look at the examples that I show in the lecture. Okay, now, what about attributes that can be derived? Now, I'm not sure we have any here. Let's think about this. I guess, so we don't have amounts that you add up, right? So we don't have the case that we are keeping some amount on an entity, and instead of doing that, it's some kind of a total, and instead we should be summarizing the detail amounts that occur on some other entity. Okay, but here's something of that kind of ilk. Um, the semester, when I was originally doing the design for semester, okay, I had the idea that I was going to have a semester name. Okay, I think I can probably add a, where is this? Semester. Let's highlight it. Yeah, let's go over here. And let's say we have another attribute. Let's call it semester name. Okay. So what I was going to do is I was going to have the semester name here. Okay. And what I can do is I can actually synthesize that out of the combination of year and period. Okay, so I've controlled the values and I'm going to derive the semester name. So when I display it, it's going to be like fall 2022, okay, which is derived from 2022 and fall, okay. So that would be an example of a value that I could derive that I am not keeping explicitly in the data model. Okay, so let's back up and get rid of that. Okay, and again, if you find some attributes you have in your data model that can be derived, well, remove them with the expectation that when you're using the database that you implement from this logical database design, you will derive them as part of your query, as part of your select, um, when you need them. Okay, and again, if you need to see some more details on these kinds of problems and how to solve them, look at the examples I've given in the lecture. Okay, what's the next one? Um, Remove redundant relationships. Okay, do we have any redundant relationships? Well, I don't think we do. Okay. One of the things that we did with our conceptual data model before we began is that we looked for redundancies, specifically in relationships. Well, let's kind of talk about what a redundant relationship might look like if we had one hanging around in the model here. Okay, so let's say that we wanted to do this. I mean, here's a way to get a redundancy. Let's say that somebody had the idea that they wanted to really get a really quick answer to the question, which instructors are teaching which courses? Okay, so they would think, okay, let's draw, okay, a relationship between the course and the instructors that teach them. Okay? And let's see what you do. You would give that you'd make that a dashed. You'd make this say one and only one. You'd make this one say 0 to many. Okay. And you would call the relationship teaches. Okay? Now, to the uninitiated, this looks like a good idea. Okay, here you have a relationship immediately on instructor that you can chase immediately to course, or from course immediately to instructor. The problem is it becomes a duplicate fact because we've already recorded that fact in by saying that a particular instructor teaches a course section, and that section is for a course. Okay, and as you can see, we have a circuit here. Okay, and if you're experienced with relational databases and the way that we do the queries, you're going to know that we don't need this teaches, so let's get rid of it. Okay, because all that we have to do is a select where we select from instructor, join course section, join a course, and we get the same information without a duplicate fact. Okay, so if you need some more examples of how you could have this kind of problem and how to solve them, well, look at the examples that I show during my lecture. Okay, what's next? Okay, the next one is relocate misplaced attributes. All right. Now, I don't think we have any misplaced attributes. Okay. So let's imagine what it might look like if we misplaced an attribute. Okay. Where could we misplace the attribute? I'm going to pause and I'm going to think up a good one. It didn't take me long. Okay. Uh, you'll notice that I have a different password for each class meeting. Okay. And the thing that I like about this, here's the idea of the class meeting password. Okay. My idea is the students are going to come to class, right? And some of them are going to log in. Well, let's say we're holding the class in some kind of a lab. So there'll be a university owned computer there. So they'll log in, they'll select the class that they want to register their attendance for, and then they'll say they want to register their attendance, and then the system will say, well, what's the password for today's class? And they'll look up on the board and it'll say Rumpelstiltskin. And they'll type that in, and that'll be the right one. It'll say, okay, I've marked you as have attended the class. Okay, well, that works fine. But what if we had accidentally put the password up here on the section? Okay, so we would have it up here. All right. Well, then the problem would be that we would have the same password for every class meeting. Okay. Well, that would work fine until you had a person who didn't come to class and they wanted to appear to come to class. And so they would log in and they would be, then they say that they wanted it to be marked as present for the class. And it would say, what's the password? And they go, I think it's Rumpelstiltskin. And they would type it in. It goes, fine, you're here. So that having one password per course section, okay, we put it in the wrong place. It really belongs one password per class meeting. Okay. So I think we put it on the wrong place, but this would be a classic misplacement of an attribute if we put it up there on course section. Okay. If you want more examples of how you could put an attribute on the wrong entity, consult the examples that I show in my lecture. Okay, what comes next? Oh, misplaced relationships. Now, do we have any of those? Well, I don't think we do. Okay. Now, I may have one, but it turns out it's one that I believe in, and you're going to have to talk me out of it in class. Okay. So I don't have one that I'm going to be talked out of. But let me pause here and I'll think one up for this. Okay. Okay. I've come up with an idea. Okay. So right now I've got semester has a period, okay, and has a year, okay. And I'm thinking that the year will be 2021, 2022, 2023, and the period will be spring, summer, fall, and you know typically between the fall and the spring, there's like a winter break period, and we may have more periods than just spring, summer, fall. Okay, now um, we could have we could have put year and period as attributes on on the uh, on the semester entity. Okay. Now what would that mean? Well, it would lead to lots of duplication. Okay. Um, for what? For the period name. Oh, okay. So what would happen is, you know, we would have to type in the value fall for period. Fall, 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 fall. And let's say we decided that it should be called autumn. Well, we'd have to change it on all the instances, right? We have that. So we really do better to control the values by having uh, a lookup entity for year and a lookup entity for period. Okay. Now, this is the correct design. Somebody might be talked into doing the following. Let's get rid of this relationship. Okay. And let's put it over here. Okay. And then have a relationship from year to period. Okay. You could easily, as a beginner, you could begin to think that, oh yeah, each semester is for a year and a period. Well, that doesn't make sense. Why doesn't that make sense? Well, uh, each of these would have been an individual attribute had we coded them directly on a semester. Okay. And so each of them should get their own independent relationship to semester. Okay. So we're going to undo that change that we talked about doing, and we've solved this. Okay. So if you want to see another example of how you could have a misplaced relationship, I give a good other example of this in the lecture. Now, one thing I'm really realizing that I don't explicitly have in my list of things to do, I probably should have had it on the list, so I'll talk about it here, is I don't say to replace free-form text fields with lookups, with relationships to lookup entities. And why don't I have it here? Well, because I encourage practitioners to do this when they're doing the conceptual data model. Okay, so let's look at what it would look like if we had not done it this way. Okay, so again, let's get rid of the period table. All right. And let's get rid of the year table. Okay. And then let's give this semester table two more attributes. Okay. And then we could put semester. I'm sorry. We could put year, and we could put period. Okay. And we could put that right there. And we can put that right there. Now, is that wrong? Well, I think it is. Okay. The reason it's wrong is that the period, especially, we're not going to control the values, right? And so each instance of semester is going to have a free-form field for period. And, we're going to be typing in fall, fall, fall. And what if we misspell fall? What if we accidentally type full or full or fold? Okay. Well, then we're going to have some data that we're not able to find. Oh, okay. So year, it's not as big a problem because we're headed for relational databases anyway. Okay. And relational databases build their relationships with foreign keys. Okay. And the fact is that the difference in our database by having a literal year value here or having a relationship to a lookup table, um, it's different. You know, we're better with a lookup table than we are without. Okay. But the reality is, it's not as big of a difference. If if we type for a whole bunch of instances, we type in the value 2023. Okay. Well, we're not going to decide that 2023 is suddenly not a good name for that year, and we want to call it, 42 BC. No, we're not going to do that. But with a period, we could easily decide that instead of fall, it's going to be called autumn. Okay. And instead of winter, it's going to be called ski season. Okay. That's entirely possible. And that's where you really see um, that it's short sighted to code free-form text fields um, into a design. You always are going to do better with uh, relationships to lookup entities or to look up tables. So let's undo all these. Let's go back and get our two lookups. So even though I don't officially have this on the list, it probably should be on the list as F, okay? Replace free form text attributes with relationships to lookup entities, okay? And the next time we teach this section, I'll add it to everything, okay? I promise I will. Okay, are we done? Well, we're almost done. Let's look at our list again and see what's left. Okay, so we need to translate the design from how it sits right now, which is it doesn't have all the parts that exactly work with the relational databases. We need to transform it so that it's appropriate for a relational database. So the first of these is resolve many-to-many relationships. Okay, let's go take a look at that. Do we have any many-to-manys? We do. We have many-to-many between user and role. Okay, and possibly you could have two or three or four. Okay, sometimes if you had what it would have been a many to many, but the relationship has to carry data. Um, the classic design for this is when you have a three table kind of e-commerce design with order and order item and item. Okay, what is order item? Well, it's really a relationship that carries data. It's a many-to-many relationship between order and item that has to carry data like quantity and actual price. So if in fact you have something like that, you probably already have a you probably have already added an associative entity. But if you have a many-to-many that you diagrammed explicitly and you don't have an associative entity in here yet, now's the time when you have to add one. So let's get that done. So here's what we're going to do. We're going to get rid of the relationship. Okay, and then we're going to get ourselves a little bit more room here. Let's do this. And move this down a couple. And let's create another entity in between. Okay, and let's call this, now, okay, we need to shade it first. Where's my shading? Right here. Okay, we need to shade it first. Okay, and now we need to give it a name. So if there wasn't a term of art that refers to this relationship, okay, then we could create a synthetic name like user underscore role, okay. We know that there's a term of art because we were using a name for the relationship that was good. It was called has permission. Okay. Now, some people will call a table like this has permission. Okay. Or they might call it user has role. I typically either call it a term of art like permission, or I call it user underscore role. And I know I keep saying table, and technically when we're doing a logical database design, the term is still entity, okay? But I can't help myself. Sorry about that. Okay, so let's get the relationships correct, okay? Okay, now it's one to many on each side. How do I know that? Well, I've been inserting associative entities into these designs for 40 years or more. Okay, and I know that when you insert an associative entity that has a many to replace a many-to-many relationship, the associative entity gets a many-to-one relationship on each side. So how do we draw this? Well, we draw the one side on user, and it goes down, and it goes to the many side on permission. And we draw the one side on role, and it goes to at the many side on permission. So the many side is always up against the associative entity. Okay? You don't even have to think about it. It's just the way it works. All right? Now, let's get the cardinalities correct. Okay? So let's see. On the one side, it's one and only one. Okay? On the many side, it's zero to many. Okay? And then let's get the cardinalities right on the lower one. One and only one. Zero to many. Zero to many is right there. There you go. Now, should these be solid lines or should they be dashed? Well, it's going to turn on whether or not you're going to give this entity its own independent ID. Okay. Now, some of this is kind of a matter of style in terms of database design. There are some designers who design a relational database that every table, even the ones that implement associative entities, get a one field integer key. They get a simple identifier key. Okay. There are some people who don't go that far. Okay, so if you weren't going to automatically go that far, how would you decide if you were going to borrow the primary key? So one thing that you can do is that you can say that we're going to use role ID from user, and we're going to use, oh, that's not role ID, that's user ID. Sorry about that. User ID from user, and role ID from role. And we're going to make both of these IDs ID ID. Okay. And that's it. We're going to stop right there. So if we were going to stop right there, we would make this one shorter. We'd make it 3. Okay. All right. Well, that's a possible thing to do. Uh, Now, if you do that in the notation that we're using for our ERDs, which is this IE uh, notation for information engineering, okay, we use solid lines to say that this is a weak entity because it borrows its identifiers from the neighbors. Okay, now, is there any real problem with that? Well, the only limitation is that you can only have one instance, between a particular user instance and a particular role instance. You can only have one permission for it. So, user Kevin, okay, can only get permission to play the role of instructor one time. Well, that's all you need. It doesn't really mean a lot to get a permission to play the role of instructor more than once. You either have it or you don't. Okay? So, in this case, I think this is a pretty good design just like it is. If you have an associative entity, okay, like in the classic 3-table design for e-commerce, and so the primary entities are order and item on the two ends, and the associative entity in the middle is order item. If in fact you don't give it its own independent ID, or if all you do is to borrow these 2 keys from the neighbors, you do have the problem that you can only have one order line, while one order line for the same item. So you can't buy 20 Pentel pencils at $5 and 10 at $20. Okay? So there are times when you don't want to use this exact identifier scheme, in which case you give it its own independent ID and you would turn these lines dashed. Okay? Like that. But we're not going to do that. We're going to leave them solid. Okay? Because I think that's okay, just the way it is right there. All right? And that one is done. Okay. So do I have any other many-to-manys that are not implemented with an associative entity? I don't. You might have in yours. Okay? In which case you would go do that. All right. Is there anything else left to do? Yeah, there are. There are a couple more things that need to be done in order to, sort of implement the relational database technologies. B here. Convert all unique identifiers to primary keys. All right, let's do that. Now, this is really easy to do. You just go around your diagram and you take everything that says ID and you type over PK for primary key. It's that interesting. It's that easy. It's not interesting. It's easy. Now, one problem that I get sometimes when I'm using a lot of these diagrammers is I go to select a field, I go to highlight it, I double click on it, and I can't. Usually, if you just magnify the drawing and you come back and you double click on it, it'll highlight. So it seems to be an artifact of the field being too small. And this happens on lots of diagrammers. So we're just going to go around and turn things into primary keys. Okay. And let's make this primary key. And student, make that a primary key. And user, we're going to make that a primary key. And role, we're just going to make that a primary key. Now, because we decided to not have a sort of independent identifier for permission, it's going to have a two-part primary key. Okay, so we have to turn both of these IDs into PKs. That's it. It's that easy. We've done it. Okay. Very good. Are we done yet? No, we're not done, but we're almost done. What's left to be done? Well, the last thing that we have is add foreign key attributes. Okay, let's do that. So, foreign key attributes. So, these relationships that we drew, most of them we drew back when we had conceptual data model. In conceptual data models, they have what I might call high magic. Okay, they don't need to provide all the detailed features to implement design features like relationships. But when you get to relational databases, which is what this is a logical design for, they don't have high magic. Okay, that's why we couldn't implement a many-to-many directly. They don't have that feature. Okay, so what's the feature that they use to implement relationships? Foreign keys. So foreign keys are attributes that occur on one of the entities that point to an instance on the other entity. Okay, so we talk about a foreign key table and a primary key table. We talk about a foreign key entity and a primary key entity. A lot of times there's a term that's I consider it helpful. I don't know if everybody does. Parent and child. So we'll say that the primary key table is the parent, and the foreign key table is the child. In every case, if we have a one-to-many relationship, like we have between course and section. Course is the one side. Course section is the many side. Okay. Then we can, so course is the primary key table. Course section is the foreign key table. Okay. And you might say the course is the parent table, and course section is the child table. Okay, so where does the foreign key go? It always goes on the many side, or another way to say that is it always goes on the child side. So we've got to take course section here and highlight it and get in another row down here so we can put in a foreign key. So foreign keys have the same name as the primary key field. Okay, so we're going to say course ID. Okay, and we're going to come over to this left column, which we can't get to highlight, so we'll make it a little bigger. We're going to come over and say FK, foreign key. That is it. Okay, so the magic that implemented this relationship in a conceptual data model has now been replaced by adding a foreign key attribute to the child side or to the many side uh, when we've gotten to logical database design. Okay? All right, let's do a couple of more of those. Okay? So, um, let's see. Semester is on the many side of both of these. Okay? So semester needs a foreign key for year and a foreign key for period. So let's make this 2 slots bigger. Okay. And let's have the year ID. And let's have the period ID. Okay. And then let's put an FK here. And then FK here. Okay. So, where did the foreign key go? Well, it went on the many side of each of the relationships. Okay, so you only put it on one side. You don't have to put it on in both of the tables. Well, how does that work? Like I always kind of worried in my kind of early days with relational databases. And I would think, well, if I have a foreign key over here on semester, it's very easy to look up the year because I know that I'm going to have, when I implement the database, I'm going to have a primary key index for year. And I know it's very easy to look up the period name because I have a primary key index for that. But will I be able to do queries where I say, what are all the semesters that use the period fall? Or what are all the semesters that use the year 2025? Well, it turns out that when we create these foreign keys using the schema code, when we do the physical database design, every time we create a foreign key constraint, we also create a foreign key index. So there's also an index associated with each of these foreign keys connected to the semester table. And every time we try to navigate the relationship from the parent table to the child, which would be from the period to the semester, the database server uses the foreign key index in order to be able to quickly navigate in the opposite way. So each of the relationships that we have is as easily navigated in either direction. Okay? And we can do that by only having to point in one direction because we generate these foreign key indexes. Pretty cool, huh? All right, so we've got that. All right, so what you do is you go around your design and you look for these many sides and you make sure that they're implemented with foreign keys. So we've got many side in course section. We've got the course ID. Okay. We have the semester ID? No, we don't. So we have a many side where the foreign key isn't implemented yet. Okay, so let's highlight that, give it another slot. Okay, we did. Let's add semester ID, not caps, semester ID. Okay, and let's make that a foreign key. Very good. Okay, do we have everything that we need? Well, we've got one many side, that's course ID, another one, that's semester ID, but we have a third. We've got registered for, we've got a many-to-many. Oh, look at what we did. We had a many-to-many that we didn't implement a, we didn't implement an associative entity. Okay, we'll come back and we'll fix that all by itself. That'll be the last thing that we do. Okay, how about that? So this is a good thing to check when you're looking for foreign keys, right? You want to look at each of the entity boxes and say for each of the manys that connects onto it, we need a foreign key. So we're missing this one here. That's okay. Course doesn't have any manys. Year doesn't. Semester has two, year and period. That's taken care of. We got a problem with section. What about instructor? Doesn't have a many. Okay. What about user? Okay. Well, here's something that's interesting. I have a relationship is student user, okay, and it has a many here, but it shouldn't, okay. This should be a one-to-one, okay. Each student is a user. This should be one and only one. So let's fix that. Okay, so where it currently says one to many, zero to many, it should say one and only one. Okay, we fixed that problem. And let's say is instructor user, okay, this should have a one and only one at this end. It does, we just can't see it. Let's do that. Pull that, there we go. We pulled the label. Okay. Maybe we'll do that. Yeah, okay. So that's good. So user doesn't have any manys since we fixed that problem. Okay. Let's look. Role doesn't have any manys. Okay. Permission. Okay, it's got two manys. Okay. So the user ID and the role ID are going to act both as the primary key and the foreign key. Okay, how do I do that? Well, here's how I'm going to do it. I'm going to go up to the top of this box. I'm going to try to drag this box out. Okay, let's highlight the box. Let's drag it off to the right. Okay, so we're going to say here, PK comma FK. Okay, and then we're going to say here PK comma FK. Okay, maybe we're going to have to make this a little bit bigger to the left too. Okay, and maybe we're going to have to, let's see if we can do this. Can we pull this? Yeah. We can pull that little divider over. I got up right by that little box and I pulled the little divider over and I got what I wanted. Okay. All right. Then maybe it's not as pretty as I wanted, but these are both primary keys and foreign keys. Okay. So that worked fine. So have I taken care of all the manys? I'm getting close. All right. Student isn't a many, instructor isn't a many. Remember these because these are one-to-ones, okay? And one-to-ones have to be implemented with a foreign key as well, but we'll come back to them. Okay, let's look. Class meeting has a many. Does it have a foreign key? No. Okay. So it's a many-to-many as well. It's another many-to-many that I missed. Holy cow, I missed two of them. All right. Well, we're going to have to fix that. All right. So here's what we're going to do. We're going to take this class meeting and we're going to move that over there. Okay. And we're going to take this course section. Let's take this. And we've got that. Okay. And let's take this as meaning. One of the things I wish these diagrammers, this lucid the chart, were better at. It's good at a lot of things, but one of the things I don't seem to be able to do is to pull these arrows around, pull these things. So it doesn't seem to want to pull them. Now, I just don't seem to be able to do it. So I have to take an as meaning here, which is has the meaning is a 0 to many, and I'm going to take this and I'm going to redraw it. So I'm going to do this. Okay, just going to do it right here, and I'm going to turn this into dash line, left part one and only one, right part 0 to many, and I'm going to change its name to has meeting. Okay. All right. So I gave us some room. Okay. So now I've got to put in two more associative entities. Okay. Sounds good. Attended meeting. All right. So let's take this one out. Okay. And let's put in an associative entity. Okay, just put it right here. Okay, and let's remember to shade the header. Okay, and let's call it attends. Or in this case, I don't think we're not going to put a row into the table unless it's been attended. So let's just say attended. Okay, we'll put this one into past tense because it's an event that's already happened. Okay, and we don't have any of this intersection data, so we're just embodying the attended relationship between student and class meeting. Okay, let's draw. Let's figure out what the identifiers are. And I'm going to say that we're going to borrow them from the neighbors. So we're going to make this one student ID. Okay. And we're going to make this one class meeting ID. Okay, and do we need it to be any more sophisticated than this? I'm going to say not, because as you will remember, the consideration that we have is, can this occur more than one time? Okay, and you can only attend a particular class meeting one time, okay? You can't do it twice or three times. It's either 0 or 1. Okay, so that's fine. So let's say student ID is a primary key. And let's say class meeting ID is a primary key. And let's make this only 2 slots. And we've got to draw across this divider so we can say primary key, comma, foreign key. Okay, it's both. We're going to do the same thing here, primary key and foreign key. Okay, and so you you may remember that when we do this, we draw a solid line. Okay, where does the many side go? It always goes up against the associative entity. So we're going to draw it from student down to attended. That's going to give us the many against attended. And we're going to go from class meeting over to attended. All right, that's going to give us that. All right. Do we need, okay, so let's get the cardinality indicators exactly right. So do we need it to be a dashed line? No, because when we're borrowing the primary key from the neighbors, we use this in the information engineering notation that we're using. You get a solid line when it's an identifying relationship. So that's what that is. Uh, some people call this a weak entity. All right, which is to say we don't want instances of attended to persist when instances of the neighbors have been deleted. Okay? Does it need its own relationship name? No, in my classes, we typically don't give these relationship names. The name of the relationship is attended. Okay? All right, so we need to get the cardinalities exactly right. Instead of one, it should be one and only one. Instead of many, it should be 0 to many. And we need to get this. Again, the solid line's okay. Instead of one, we say one and only one. Instead of many, we say 0 to many. Okay, that looks good. That one's done. So now we've got the register for. Okay. Let's solve that. Oh, one of the things that you don't really have to do with this lucid chart that works in the cloud is I don't think you have to worry too much with saving as you're going along. Every once in a while I get worried, has it been saving my work? I think it's been saving it in the cloud the whole time. Okay, so I just did a save there. If you want to do it more often, well, maybe you'll be a little safer than me. Okay, so we've got this register for relationship. Okay, let's get rid of that. That's a many to many. And we have to build an associative entity. Okay. And what do we call those? I'm going to say that we probably call that registration. So first of all, we need to shade the header. Okay. And let's call that registration. That's a kind of term of art that you would use for this. Okay. And I think we're just going to do a simple identifying relationship kind of thing. We're going to borrow the keys from the neighbors. Okay, so let's do the following things. Let's highlight this and make it longer. Okay, let's pull this around so we can put the PK and the FK. Okay, and then the neighbors, we've got course section ID. That's one of them. Course section ID. And then the other one is student ID. Student ID. All right. Okay. This isn't a 3-slot box. We should reduce the slots to 2. Okay. And then what are the, in the ID column, we're going to put PK, comma, FK. And we're going to do the same right here. It's both a primary key and a foreign key. Okay. So let's bring this down here so we've been enough room to draw things. All right. And where will the many side be? The many side is always up against the associative entity. Okay. So let's draw from the one to the many. And let's draw from the one to the many. Okay, that looks fine. We're okay with solid lines. We're okay without names because the name for this relationship is registration. But we do want to get the exact right cardinalities. So let's go up and make this one and only one. And let's go up and make this one 0 to many. And then let's come up and do the same thing. One and only one. 0 to many. Okay, that looks pretty good. Are we done yet? No, but we're darn close. Okay. Okay, so we've done all the one-to-manys. We've done all the one-to-manys to begin with. Then we went one of the things that we found out is that we had many-to-manys that we never resolved with associative entities. So we resolved two of those that we had forgotten. Ooh, that was bad. Okay. So now the only thing that's left is we have a couple of one-to-ones. Okay. Now, in this case, we're going to say we've got a 1 to 0 or 1. So a user may be an instructor. A user may be a student. Okay. I mentioned earlier it's theoretically possible for a particular user to be both an instructor and a student. Is it a problem that the cardinalities of our diagram are not fine enough to express that directly? No, it's not. It's just a limitation of cardinality notation. What will eventually constrain the data in the system? Well, whatever application we build to populate the data, to do the CRUD functionality for the database, to do the inserts, the updates, and the deletes. Oh, okay. Whatever application we build that's going to do that is going to truly enforce all the business rules, including the nuances of for each user, are they an instructor or a student, or in rare cases, are they potentially both? Okay? So, who's going to point to what? Okay? I'm thinking that I kind of like the idea that the instructor is going to point to the user and the student is going to point to the user. Okay, so let's do that. Let's have a foreign key on instructor. Let's give it one more slot. Okay, in which case we're going to give it a user ID. And that's going to be a foreign key that implements that relationship. And let's come down here to student and essentially do the same thing. Give it one more slot. Say it's going to have a user ID to make that work, and that's going to be a foreign key. Okay? Now, one last thing that you can do is you can go through the diagram and look at every one of the relationship lines and convince yourself you have a foreign key that implements it. So let's do that. Let's go to the top. This is a relationship line. The foreign key is course ID. Okay, that's good. Has year ID. Has period ID. Okay, those are all implemented. Okay, for semester ID, that's implemented. Okay. Has meaning. Um, you know what? We don't have a course section ID that implements has meaning. Let's get that fixed. Okay, so let's give it one more slot. Course section ID FK. All right, so our checking solved a problem. Okay, so for semester ID, for course ID, that one's fine. Registration, course section ID, student ID, we've got them both. Let's look at instructor. Okay, it has one foreign key, user ID. Student has one foreign key, user ID. Okay, that's good. Let's look at attended. It should have two foreign keys, student ID, class meeting ID. That's fine. And role doesn't have to implement anything. Permission has a role ID and a user ID. That I think should probably do it. Okay, so this checking, like I'm showing you here, is the way you get it done. All right. So it's pretty tedious. I mean, it was quite a bit of work if you consider that we did the normalization. And even one step of the normalization wasn't explicitly in the list. You remember that I said that we have to imagine that we have an F, which is to replace all free-form text attributes with relationships to lookup entities, okay, which in my approach we usually do in the conceptual data model. But you consider that we had this whole list of things to do. Most of these were already done because we had kind of taken care of them when we did the conceptual data model. Even with that, there's plenty of work to do. Just resolving the many-to-manys, converting the unique identifiers to primary keys, and adding the foreign key attributes. That's a lot of work. Okay. So I'm pretty happy with this. Okay. I'm going to print this out so we can talk about it in class if we need to. But that's the logical database design for the tutorial example. And I'm going to stop here and say bye until next time. Bye-bye.